Greetings to all the viewers. I'm N. Usha from 2nd MSc Microbiology, Sacred Art College, Autonomous, Tirupatur. I'm here to share about design of fermentor and factors affecting the fermentor design. First, we'll see about what is fermentor. A fermentor is a closed, sterile vessel that is designed to provide a controlled environmental conditions such as the temperature, pH, aeration, and agitation for the growth of microorganisms or cells to produce a desired biological products through the fermentation. So this is a design of fermentor. The fermentor vessel that contain motor, mechanical seal, agitator shaft, impeller, exhaust outlet, air inlet. It contain both acid and base, foam control agent that is anti-foaming agents and nutrient line, storage, pH electrode, exhaust outlet, DO probe that is dissolved oxygen probe, temperature probe, sampling port, again pH electrode, DO probe, temperature probe and drain point that is harvesting port. First, what are all the components which is present in the fermentor? First, fermentor size, fermentor vessel, impeller, impeller shaft, stirrer shaft seal, baffles, air sparger, sterile air line, aseptic inoculation pipe, sampling point, exhaust gas outlet, working level that is broth level, pH electrode, dissolved oxygen that is DO probe, temperature sensors that is thermocouple, foam sensor, heating and cooling jacket, pressure relief valve, clean in place that is CIP system, steam in place that is SIP system, harvesting port that is drain point. Fermentor size. The fermentor size which can be varies depending on the scale of operation. So it can be categorized into three types. First, the laboratory scale fermentor. The volume ranges 1 to 10 liter and it is used for research, strain development and process optimization. Second one is pilot scale fermentor. The volume ranges 20 to 1000 liters. It is used for process development and scale up studies. Third one is industrial scale fermentor. Its volume ranges 10,000 to 5 lakh liters or more. It is used for commercial production of antibiotics, enzymes, alcohols, etc. Fermentor vessel. It is a cylindrical container that is made up of the stainless steel. It holds the culture medium and microorganisms. It is also resistant to pressure, corrosion and high temperature. Impeller. Impeller is a rotating blade that is attached to the shaft. It provides the uniform mixing, prevents from the cell settling. It enhances the oxygen transfer also. pH electrode. Continuously monitor the pH, control the automatic acid and alkali addition. Impeller shaft. Impeller shaft, it transfers the motion from motor to impeller. It must be precisely aligned and sterilizable. Sterile shaft seal. It prevents the leakage and from the contamination. It maintains the aseptic conditions during the agitation. Baffles. Baffles is a vertical strip that is fixed to vessel wall, prevents the vortex formation, mixing the efficiency and oxygen transfer increases. Air sparger. It is located at the bottom of the fermenter. It supplies the sterile air as fine bubbles. It improves the oxygen availability in the aerobic fermentation only. Sterile air line. It supplies the filtered air to sparger. Air is sterilized using the highly efficient particulate air filter that is HEPA filter or membrane filter. Aseptic inoculation pipe. It is used to introduce a starter culture. It prevents the entry of contaminants during the inoculation. Sampling point. It allows the withdrawal of broth without contamination, used for the checking of various pH, biomass, substrate and product. Exhaust gas outlet. It releases the carbon dioxide and waste gases. It is fitted with HEPA filter to avoid the contamination. Working level, that is broth level. It indicates the volume of fermentation medium and it is also maintained the below total volume to allow the aeration. Next, the dissolved oxygen, that is DO probe. It measures oxygen availability which is present in the fermenter. So adjust the aeration and agitation automatically. Temperature sensor, that is thermocouple. It maintains the optimum growth temperature. So foam sensor, it detects the foam formation and activate the anti-foam addition automatically. Heating and cooling jacket. It occurs surrounds the vessels. It maintains the temperature using the hot or cold water. Pressure relief valve. It prevents the excessive pressure buildup in the fermenter, and it is also ensure the safety. Clean in place system, that is CIP system. It enables the cleaning without dismantling. It saves the time and prevents the contamination. Steam in place system, that is SIP system. It sterilizes the vessels and accessories using the steam. Harvest port, that is drain point. It is located at the bottom of the fermenter, used for harvesting the broth and cleaning purposes. Next, what are all the properties it requires for a good fermenter? So first, it should be in aseptic operation and efficiently mixing and aeration, accurate temperature and pH control, high oxygen transfer rate, that is OTR, and it should be the low power consumption, easily sterilization, easy cleaning, scalability from lab to industrial scale, and mechanical strengths and corrosion resistance. Next, factors affecting the fermenter design. What are all the factors are affecting the fermenter design? First, the nature of microorganisms. The type of organisms we are used, that may be the bacteria, yeast, fungi or animal cells. Oxygen requirement, that may be aerobic or anaerobic. It's sensitive to shear stress, growth rate and morphology. Next, the type of fermentation process. The fermentation process we are carry out, the batch, fed batch or continuous, or it may be solid state or submerged fermentation. Duration of the fermentation. Next, aeration system. The aeration system, it rate of air supply, type of sparger we are used, and air sterilization method we are followed. Heat transfer requirements. It metabolic heat generation, need for cooling jackets or internal coils, temperature control efficiency. Sterility requirements. It designs must allow effective CIP and SIP, that is clean in place system and steam in place system, smooth inner surfaces and minimum dead spaces. Next, pH control. It ability to monitor and control the pH, provision for acid and alkali addition. Next, agitation and mixing. It requires for uniform distribution of nutrients and temperature. It affects the impeller type, speed and number of impellers we are used. Excess agitations may damage the shear sensitive cells. Oxygen requirement. High oxygen demand requires efficient aeration and agitation. It influences the choice of impeller, sparger and vessel size. Foam formation. The foam control system and anti-foam additions may reduce the foam formation. Headspace design. Cost and economics. So operating cost, energy consumption, easy of maintenance. Thank you.